In this, we are designing a bidirectional DC to DC converter with a DC motor as a load, and in this, we apply the regenerative braking so that the battery can be charged. That is, the energy stored in the windings of the DC motor is retrieved by the battery. For that purpose, only we are using bidirectional DC to DC converter. This is the simulation of the bidirectional DC to DC converter with battery as a source and DC motor as a load. In this, for operating the DC motor, we are using a controller, voltage mode control. These are the reference voltage, 48 volt, and the measured voltage is provided as feedback. It is given to PI controller. The PI controller will generate the duty ratio, which is given for pulse generation. The pulse will be provided to the boost switch if the motor is running in the forward conduction, that is traction mode. And when it is in regenerative braking, the pulses is generated is given to the buck switch. So the converter will operate under the buck mode. In this, the energy stored in the DC motor windings will be retrieved back to the battery. Here this is the battery voltage, 12 volt, 7.5 Ah. We are having initial state of charges 50 percentage, and that is given to the bidirectional converter, and the output of the bidirectional converter is connected to the DC motor, and bidirectional converter switches are controlled by the voltage mode control. Here this is the rotor speed of the motor. Initially it is around 120 radian per second, and torque is increased, so slightly that is reduction in the speed. And when we apply the regenerative braking torque, the speed goes to 0. Here if you see, at zero point 0.8 second, we are varying the torque from 5 Newton meter to 6 Newton meter, and then we are applying the regenerative braking at 1.3 seconds, and these are the voltage, current and power. Initially it is around 48 volt, and when the torque is increased from 5 to 6 Newton meter, current slightly increased and power is also slightly increased from 750 to 1000 watt. And here if you see in this, regenerative braking out occurs at 1.3 seconds. The current goes to negative and then it is nearly 0. Similarly, the power also. Power is increased in the negative direction and then it reached 0. Here if you see the battery conditions, you can see it clearly. Initially the battery was discharging, so the state of charge decreases here. At 1.3 seconds, we apply the regenerative braking, so the battery should be charged. That means the state of charge should be increased. You have to zoom it and check. Here if you see, the state of charge increases here. when we apply the braking. This is the working of the bidirectional DC to DC converter with regenerative braking for electric vehicle applications. The motor was initially in tracking, that is traction mode, so the battery was discharging and the motor was running. The torques are varied, so the power consumption also varied here. And after 1.3 seconds, we apply the regenerative braking torque. So at the time, the energy stored in the motor windings will be fed back to the battery. So the battery SOC little bit increased here. So every time we brake, we will get some supply from the DC motor. So it will increase the runtime of the vehicle.